Imagine the Earth not just as a home, but as a machine, ancient, powerful, and increasingly unstable. Supervolcanoes simmer beneath our feet. The atmosphere is warming faster than ever. Glaciers melt, oceans acidify, and humanity, we're running out of time. But what if we didn't just react to nature, but engineered it? Welcome to the edge of possibility. From cooling magma chambers to building orbital rings today, we dive into bold sci-fi inspired ideas that just might save our planet or endanger it even more. Let's start underground, deep underground. In 1815, Mount Tambora in Indonesia exploded with such fury, it blanketed the globe in ash, caused global cooling, and led to the infamous year without a summer. But even that was small potatoes compared to ancient eruptions like Mount Toba. Supervolcanoes have the potential to eject thousands of cubic kilometers of debris, enough to cause mass extinction. Now NASA has proposed something radical: drill around a supervolcano like Yellowstone to siphon off heat and generate geothermal energy. If successful, this could prevent an eruption and power entire regions. But drill too close and we might trigger the very disaster we hope to avoid. It's a game of millimeters and millennia. It's a wild idea, but think about it. This isn't just disaster prevention. It's power generation. It's turning the monster into an engine. Still, we must tread carefully. Humanity has a history of underestimating natural forces. In '91, Mount Pinatubo erupted, releasing 20 million tons of sulfur dioxide into the stratosphere. The result: global temperatures dropped for nearly 2 years. Inspired by this, scientists have proposed artificial volcanic eruptions, ejecting sulfur dioxide into the stratosphere to reflect sunlight and cool Earth. It's geoengineering at its boldest. 1 ounce of sulfur dioxide up there can offset tons of CO2 emissions. But altering the atmosphere could backfire: unpredictable weather, disrupted monsoons, crop failures. In short, sunscreen for Earth, but with potentially deadly side effects. Take the 1816 climate anomaly. Crops failed across Europe. Starvation followed, and playing with sunlight isn't just science, it's survival. If messing with the sky is too risky, what about blocking sunlight from space? MIT scientists have floated the concept of a massive solar shield made of silicon bubbles placed at the Sun-Earth Lagrange point. It would reduce sunlight by 1.8%, just enough to offset modern warming. The shield could inflate in orbit, minimizing launch weight, and be deflated if necessary. Elegant, reversible, and theoretically effective. But to work, it needs to be the size of Brazil. It's massive, it's expensive, and it's straight out of a sci-fi novel. But with climate tipping points approaching, we might soon need to choose between fantasy and catastrophe. Some solutions are beautifully grounded. In 2007, Africa launched the Great Green Wall, a bold effort to grow a 5,000-mile belt of trees across the Sahel. It's more than a carbon sink. It halts desertification, creates jobs, and supports biodiversity. Similarly, conserving natural carbon sinks like the Amazon is critical. These ecosystems are nature's balance sheets, storing carbon, cooling the air, and stabilizing weather. Communities in Senegal are already seeing crops return and water tables rise. Nature, when given a chance, heals fast. Now let's tweak biology. Scientists are modifying plants to perform photosynthesis more efficiently, growing up to 40% larger. Others are engineering algae that turn sunlight into hydrogen fuel, or microbes that generate electricity from waste. Most ambitious of all, the de-extinction of the woolly mammoth. By re-engineering Asian elephants, scientists aim to reintroduce them to the Arctic to preserve permafrost and prevent methane release. Yes, it sounds insane, But if gene editing can create resilient crops and help preserve ancient ecosystems, it may become one of our most vital tools. Technology mimics nature with carbon capture machine, mechanical trees that absorb CO2 like real ones, but at 1/1000th the rate. 100 million of these could theoretically offset all of humanity's emissions. But what about the oceans? Excess CO2 is acidifying them. One wild idea, detonating a massive nuclear device beneath the seafloor to break up rock and trap carbon. It would be 1000x more powerful than the Tsar Bomba, but contained by deep-sea pressure. We're literally thinking about nuking the ocean to solve our problems. That's how desperate the situation is and how imaginative we're becoming. Safer methods include building artificial reefs using sunken ships and concrete blocks. These stimulate marine biodiversity and act as wave buffers. They also enhance carbon absorption by shellfish and seaweed. Deployed strategically, reefs can protect coastlines from erosion and storm surges, acting as nature's breakwaters. Studies show fish populations increasing 20x in reefed zones. Oceanic cities could soon be built upon these concepts. The Thwaites Glacier is Antarctica's ticking time bomb. If it collapses, sea levels could rise by 10 feet. To stop this, engineers propose building a 100-kilometer underwater curtain to block warm ocean currents from melting the glacier's base. In the Arctic, wind-powered pumps and polar umbrellas could refreeze sea ice and reflect sunlight. We're trying to air condition the planet. The question is whether we're fast enough. Our energy consumption has exploded up 7,000% in 2 centuries. Solar power is the solution. Just 0.3% of Earth's surface covered in solar panels could power the world. Deserts are prime real estate. The Sahara alone could produce 4x our current global energy demand. But large-scale solar farms heat up the air and may disrupt global weather patterns. More energy means more waste heat. If we keep growing, Earth's temperature could rise by 20 degrees Celsius, making it uninhabitable. So what's the solution? Move our energy collection and our heaviest industries into space. Orbital solar farms could beam energy down via lasers or microwaves. Projects are already underway in China and the UK, but even beaming power back creates heat. The best option? Keep the entire industrial process off-world. To do that, we need a space elevator. A 36,000-kilometer cable stretching to orbit, enabling low-cost launches and orbital factories. It would change everything, but we don't yet have materials strong enough. Still, we're getting closer. If we can build a space elevator, we can go further, constructing orbital rings, spinning megastructures around Earth for transportation industry, and even human settlement. Floating cities, skyhooks, tethered skyscrapers. With artificial gravity from rotation, these platforms could house millions. Transportation could be instantaneous, point-to-point in minutes. Climate impact, minimal if done right, but risks remain. Space debris collisions, Kessler syndrome. We'd need AI-guided lasers, orbital drones, and global coordination. Mining asteroids would supply materials, preserving Earth's own resources. This is the grandest vision, an Earth preserved with civilization reaching for the stars. Not by abandoning our planet, but by giving it room to breathe. This isn't fiction. Every idea you've seen is backed by real science. Some are decades away. Others could be tested tomorrow. But the goal is clear: engineer Earth not for conquest, but for care. To survive the next 1,000 years, we must think bigger, act faster, and dream bolder than ever before. Welcome to the age of planetary engineering.